Hey guys, in this video we are going to talk about trees. So tree is a hierarchical data structure where nodes are connected through edges and they do not have any cycle. Let's see how. For example, if we try to draw a tree, this is an example of tree. And you see there are no cycles. If we draw cycles like this, if we connect this node to this node, then this will become like a graph. So this is one important thing that you need to remember. Tree doesn't have any cycles. This part of tree is called root, the topmost node. This part is called internal nodes, and on the bottom these nodes are called leaf or leaf nodes. So let's talk about the first type of trees. Binary tree have a very simple condition that says at most two children. So any node can have at most two children. Let's see how. For example, if we draw a tree like this can be called a binary tree. Why? Because this node have one child, so which fulfills our condition of having at most two children. So if we draw like this is still a binary tree because the root node have two children. And if we draw something like this, then this is not a binary tree. Why? Because this root node have three children. So let's talk about the next type of binary tree. So the first type of binary tree is full or strict binary tree. Guys, this kind of tree has only one condition, either 0 or 2 children. So I have drawn a full binary tree. Let's see how. This node have 2 children, which fulfills our condition of having 0 or 2 children. This node have 2 children, so which is also fine. Now this leaf node have 0 child, so this also fulfills our condition. So this is a full or strict binary tree. Now if I draw an edge here like this, now this is not a full binary tree. Why? Because now this node have one child, which is not allowed. It should strictly have either 0 child or 2 children. Now the next type we have is almost complete binary tree. Guys, let's try to understand this concept carefully because the heap tree concepts are usually based on almost complete binary tree. So let's start. There are two important things that we need to remember in this case. So the first thing is we need to start inserting elements from left to right. So for example, if I draw a binary tree like this is not almost complete binary tree. This is still a binary tree but not an almost complete binary tree. Why? Because we need to fill the left side first like this. But what we were doing is we filled the tree from the right. Now let's draw an example of almost complete binary tree. This can be called an almost complete binary tree. Why? Because we started filling from the left side. Now we will fill the right side. This is still an almost complete binary tree. Now let's see another case. Now this brings us to our second point. Is this a almost complete binary tree? No. Why not? Because we need to fill all the levels first. For example, if we are at this level, we need to fill all the child of this level. So you see, when we started from here, we filled these two child and then we moved next, which is wrong. We first need to fill this part. So if we convert it to this, we fill this level first and then we move to the next level. Then this is an almost complete binary tree. Let me draw another example. For example, this is not almost complete binary tree. Why? Because we still need to fill one child at this point. So if we fill this point and then we move to the next point, now this is an almost complete binary tree. So this is the second condition. We need to fill the current level before we move to the next level. Now the next type we have is complete binary tree. Binary tree have one condition. Let's see what's that. Complete binary tree have one condition that says all nodes except leaf nodes should have two children. Let's see how. For example, if we draw a tree like this, this is a complete binary tree. Why? Because every node have two children, you see, but the leaf node have zero children, which is fine. Leaf node should have zero children. Now there's one more condition that we need to understand. The second thing. Now there's one more condition that says a level should be completely filled. Let's see how. For example, if I draw a tree like this, is this a complete binary tree? No. Why not? Because this level is not completely filled. There is still some space of having children at this point. So if we add children at this point like this, now this is a complete binary tree. So remember guys, you need to fill every level. Except the leaf nodes, you need to fill all the levels. So a level should be completely filled. So let's try to draw another example. For example, we draw like this. Now, is this a complete binary tree? No. Why? Because this node have one child, which is not allowed. Every node should have two children. So we will draw it like this. Now this is a complete binary tree. So remember guys, there are two conditions. All nodes except leaf node should have two child and every level should be filled. Now this brings us to our last type of tree, that is fourth type, that is binary search tree. So binary search tree have one condition that says now this says greater element should go on the right side of the parent node and smaller elements should go on the left side of the parent node. So we are basically introducing order in binary tree. So let's see how. For example, if we are given with a stream of data like this, let's try to draw its binary tree. So 5 will go at the top. Now 3 is smaller than 5, it will go at the left. Now 2 is smaller than 5 and 2 is smaller than 3, it will go on the extreme left. Now 4 is smaller than 5 but 4 is greater than 3, it will go on the right side of 3. Now 10 is greater than 5, it will go on the right side. 13 is greater than 5, 13 is greater than 10, it will go on the right side. Now 12 is greater than 5 and 10 but it's smaller than 13, it will go on the left side. So guys, this is an example of binary search tree. So guys, that's all for the trees. This is AJ signing off.